we will now have two contributed talks, and there'll be a short Q&A session after each speaker. So please do think up questions during the talks. The first talk will be from Michela Botticelli, a research associate from the School of Culture and Creative Art at the University of Glasgow, who I need to go and find the microphone for.
Thank you. Right, so can you hear me? Okay, good morning, everyone. I'm Michela, and I'm really pleased to be here today and to present this work, very interesting research topic at the University of Glasgow and the Kelvin Centre for Conservation and Cultural Heritage Research, together with the Ontario Museum, which is the place where these miniatures belong to, and that's the subject of my presentation today. So this is a very specific production of the 19th century, but Indian portraits were quite common since the 16th century indeed. At that time, they had a different meaning, though, in the sense that they were intended at national scale to introduce the power of the emperor and portray the emperor Mughal line. But then they became a different product, and they were, at the time of these miniatures here, they were meant to be souvenir products for the British market and for the European market. As you can see here, there's also the penny magazine, where the way these emperors were portrayed and then reproduced in magazines or on ivory is quite much the same. So we see the emperor in profile, head and shoulders, and it's painted on ivory, usually in oval shape, sometimes with a frame. So it's a pattern, and we see series not only at the Ontario Museum, but also in other collections, for example, at the V&A or in private collections. So we can really cover the family tree of Mughal emperors if we take a look at the series we have at the Ontario Museum or somewhere else. So before the reopening at the Ontario Art Gallery, the conservation manager and the curator came to us, and they had very specific questions. So they wanted to know what the original materials of these miniatures were, and because they wanted to know the best conditions for display. And in particular, we decided to study the three miniatures you see there, because we thought they could be representative. And we decided to use micro-FTIR spectroscopy, thanks to the CAPCO funding, the Kelvin Centre at this new instrument. And so we decided to use the technique because it has the advantage of being non-destructive if we use it in external reflection. And it's particularly good for these miniatures that have the size of my palm, more or less. So they can be hosted under the microscope, and we can really decide the point we want to analyze. A drawback is that if we use a non-destructive way, we have to use external reflection, and this brings lots of spectral distortions in our spectrum, in our results, meaning that if we want to compare the spectrum with references, for example, spectral libraries, it can be very hard. So, but because we are working on a very flat surface with a high specular component, if we apply some transform, we can have a spectrum that is quite well comparable with a transmission reference. So let's see what we got. And the first question of the conservator was, is this really ivory? Because they are said to be painted on ivory, and we want to make sure that we are dealing with this material. So we collected some points on the emperor's shirt, for example, on the background. Unfortunately, the arrow points to the bright decoration, but the spectrum was taken from the background. So if we apply the KK transform, that is a kind of processing technique we can apply to the spectrum, the red one on the picture, in the picture. And we compare it to an ivory spectrum acquired in transmission. We can clearly see that we tackle both the organic and the inorganic fraction. So there are correspondences, and we can identify ivory in our sample. So that's the background of our miniatures, and then we took a look at the pigments. The bright decorations were made in lead white, and this pigment, it doesn't have lots of spectral distortions, or it has very specific signals in infrared, so we can clearly identify it even if we don't apply any transform to the spectrum, and that's a good point. And then we tried to identify other pigments. And if you see the spectrum collected on the green area, once again, if we apply the KK transform, we get signals that are very good, and we can compare them to a transmittant spectrum from malachite, which is an inorganic pigment, and it matches the palette of the Indian artists at that time. Another pigment we identified, this time without applying FTIR, was Indian yellow, because a preliminary observation was carried out with UV light, a simple UV lamp, and Indian yellow has this bright yellow fluorescence under UV light, so that the identification was carried out by a simple observation. And it's on the brightest details of this miniature, but also of the other miniatures. Now, the binder, it's a tricky one. And first, we noticed that in most of the spectra we collected, especially on lead white, we found some very sharp signals in the region between 1600 and 1500 centimeters to the -1. And so, and that was true for all the 3 miniatures we analyzed. And these all usually come from metal soaps. Of course, we had the metal because that was lead white, so we have lead. But we speculated on the provenance of these compounds, and they usually come from oil, so if the technique is oil. But we don't know if they might come from the interaction with a different binder. It's been said that they can also come from the interaction of the metal with egg, but we don't know if that's true for other techniques, as far as I know. So first we inferred about the possibility that the technique was oil, but then we also found some results, some evidence of a gum. So that's the tricky side of the research, and I will give you some hints later. So that's a summary of the results we had both for the support, the pigments, and binders in the 3 miniatures we analyzed. The palette, the pigments we identified is consistent with the production of these Indian miniatures and the period they were produced, but there were also some uncommon findings. So if we look at the jacket of the emperor's jacket, we can see at the micro scale that there are some good flowers. Imagine that these are like 2 millimeters in wide. So there are some very well painted flowers, and there are some badly painted flowers. And if we analyze them using FTIR, we see that these have different composition. So the first brings Prussian blue. It has a very diagnostic feature at 2085, and the other badly painted flowers add a very different spectrum, possibly bringing the presence of a different white and ultramarine. So we speculated on the presence of a later intervention that was undocumented. So the conservator didn't know about this possibility. And that's what we suggested in terms of display conditions. So based on the presence of ivory, the presence of some pigments that are subjected to fading, and the technique that we hypothesized, we suggested some conditions for display. So we have ivory that is quite sensitive to water and hygroscopic. So we suggested specific humidity conditions and also a control of the temperature. But also we suggested that the miniature shouldn't be exposed to light, and in particular UV filtered light. So that's why if you go to the Antiquarian Museum now, you will see that there are only 3 miniatures of the 10 in the collection. And they will be on display like 3 by 3. So you can go more than once and see all the miniatures, because it's quite a visit is quite recommended. Finally, some thoughts or doubts. And since these miniatures have been evolving, especially during this century, the century of production. So if we read this letter written in 1818, we see that these miniatures were not only produced as portraits on frame, but they were also for earrings, necklaces, bracelets. So there's a kind of evolution in the production, which to me also reflects an evolution in the technique. And what we know about the workshop, in Delhi there was this family-based workshop, and we know that artists in the workshop were familiar not only with the production of these miniatures, but also with copying portraits for the British market again, but using oil on canvas. So using a British technique, if you want. So my idea is that it is likely that there was a contamination in techniques and products used by artists at that time. So if you are familiar with the subject or with these miniatures, as it happens at the V&A, you're very welcome to get in touch and collaborate in order to find out more about these miniatures and this production in series. And if you have any questions, please ask. Thank you.
Okay, thank you very much, Michaela. Are there any questions? We have a couple of roving mics. So if we have any questions, not like I say at the moment. So I will start. A little bit too late. On your FTIR, you're analysing very small areas. What sort of spot size is the analysis performed on?
It's usually a micrometric size. So a few microns. We can get down to a few microns. Mm-hmm. So it's really likely that you can get to know a very specific area. Like if you're interested in a green detail, or like the bright LED white paintings and decorations, they were very fine. Mm-hmm. And so it's quite likely that you get signal from that area.
Okay, thank you. So
how reliable were your transforms for your FTIR? Did you have any trouble with consistency?
Yes. We had. That's why the interpretation, especially of the organic fraction, is quite, well, you need to really verify the signals before and after the transform, or you have to decide whether you can apply the transform or not. So the interpretation of, especially of the organic fraction, is quite tricky. The ones you see there are like of course, the good spectra, like, but there are also very bad spectra. It also depends on the surface. So it's really tricky to get a good spectrum and to decide what's the best transform is. Because sometimes they have intermediate features between a transmission and a reflection spectrum. So you have to be very careful in the interpretation.
When you're looking at your specimens, are they in air or are they very close to the source, and is it really non-destructive?
It is non-destructive in the sense that the miniature, as I said, is very small, so it can be placed on the microscope stage, and the working distance is usually around like 5 or less centimeters. So you can be close, but it's a safe distance in the sense that you don't touch your sample, you don't touch your miniature.
Thank you very much for an interesting talk. Maybe less on the science side, but maybe more on the historical side of these mini images. The new good, or the older good flowers and the bad flowers. I mean, that's a really interesting insight. Is there any, do you have any idea of why someone would actually, where those newer bad flowers came from? Or and if you saw anything on the other images, portraits?
Well, I guess it depends on fading because especially on the red areas, we could really see that there was some fading. And so I think the action was taken because the conservatory there noticed some fading and they decided to repaint. But it is completely undocumented. Like the conservation manager didn't know about it, and so it was good to see some clear evidence, both on the observation using the microscope and also the FTIR, using FTIR.
Yeah, great, fascinating, thank you.
It's a technique that clearly works very well for
tiny objects.
miniatures where you can basically put them in the machine.
Yeah.
How about something that's a bit larger?
Well, the picture I showed in the slide, it was about a book, because we also tried to use the same instrument for a book, for an ancient book. So in theory, you can use every object that can be hosted on the microscope stage, and that is not too fragile to, be affected by any mechanical movement, because the stage moves during the analysis. If you want to analyze like a nearby area, you have to move the stage. So
right.
It moves with the object. So you have to be careful in placing your object on the stage and under the microscope, but it can be done for several objects.
Okay. Any other questions? No? Yes. There's a microphone on its way, sorry.
Does this micro-FTIR works with cross sections too, or just
Yes,
by placing?
that's the most common application.
Okay.
So, but the problem there is that you have interferences from the embedding resin, so you have to make sure that you can somehow distinguish between the signals coming from resin and your sample. Or we also tried, together with Valentina, we tried on unpolished and unembedded samples, but in that case you have non-flat surfaces, so if you use external reflection you will get like much more spectral distortion. So again, drawbacks and advantages.
So the important thing is to have a surface that's as flat as possible.
The interaction to favor like the correct interactive angle with the infrared light.
Right, yeah. Okay, any more questions? No? Okay, can we thank our speaker again? Thank you. Okay.